Hello, PreCalc. We have a test tomorrow. 5-1. May Day, May Day, May Day. I'm not sure how far we got on this review in class. There might be 10 problems here for you to look at tonight. So I'm setting up this video as if that's what you had. So if we've already covered some of these in class, just skip ahead to where we stopped. All right, there are crayons, and they are violet, indigo, blue, green, yellow, orange, and red. Roy G. Biv. Colors in the rainbow. Can you find the probability of selecting one, and we're talking about a random selection here, which is neither green nor red? So there's 7 colors in all. To meet the requirement, not green, not red, that would be a total of 5 other colors that would meet that requirement. So you would divide 5, meeting the requirements of the problem, divided by the total number of colors, 7, 5/7. So the answer is not that. The answer is the probability of no green and no red, 5 out of 7. All right, number 2. 2 dice are rolled. What is the probability of rolling a pair that sum to 2 or 6? The word or between 2 and 6 means to find the probability of rolling a 2 and adding. Or tells us to add, and the probability of 6. So we need that little chart, which I just allowed to peek at you. And that chart looks like this. Here's the probability, or the counts for all 6 sides on one die, 6 side on the other. So the 2 dice have all these combinations of possibilities. So what's the probability of 2 or a 6? The probability of 2 is 1 out of 36 possibilities, and the probability of 6 are 5 out of 36. So when you add those together, you get 6 over 36, reducing to 1/6. Always reduce. All right. Number 3. "300 people got traffic tickets last week." Oh, the glare. It's worse. 300 people got traffic tickets last week. 200 were men, of whom 50 complained. And of the 100 women ticketed, 8 complained. What is the probability that a ticketed person complained last week? So we're going to do that probability by the probability of complaining is the number of complainers divided by the number of people total. So we're going to have to add to get the number of complainers, 50 and 8, 58, divided by the total people, 300. So let's find that work. These are out of order, that's why I'm making such a mess here. All right, so the number complained, 58 out of the total 300, reducing to 13 out of 75. All right. There were 7 round rocks and 5 square. 7 are chosen randomly. What is the probability that 5 of those are round? So we set that out with 5 are round out of the 7 we're going to choose. So we're going to pick some blanks here. 7 are chosen, 5 have to be round, and the other are square. So looking at the numbers again, how many ways, and that's going to be over, let's do the denominator first. 1, 2, 3, 4, 5, 7 are chosen, 1, 2, 3, 4, 5 are on, all right, round, I have 1 blank too few. So on the bottom here, I have to have 7, 1, 2, 3, 4, 5, 6, 7. So how many rocks were there total in this problem? 7 round 5 square, so that's 12. So there's 12 ways we could pick the first rock when we had no special conditions. So we have those numbers, and on the top, how many ways could we pick a round rock? Again, there were 7 possible round rocks, so we have 7, then 6, 5, 4, 3. And when we go over to square, there are 5 ways we can get a square, and then 4. However, that's only part of the story. As we recall how these work, it turns out this is just one arrangement of this. So suppose I had this one, round, 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 square, square. That's what this represents. So the numbers would be 7, 6, 5, 4, 3, and then 5, 4, like indicated. But I could have had square, round, 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 square, like that. It could have been drawn in that order, which would be represented by the same numbers. We still have a 5 above this square and a 4 above this square, and a 7, 6, 5, 4, 3. So I'm not sure what that number is. Let's see if I wrote it down. I did not. So anyway, let me just keep explaining here. So now, what if I have had round, square, round, 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 square. So this is another one. So this could happen, or this could happen, or this could happen. And again, the numbers are the same on each row. We would still have a possibility of 5 over this S, a 4 over this one, and the rounds would be 7, 6, 5, 4, 3. So these could keep repeating a number of times, and each one is a possibility, so we've got to count that. So the way we do that, once we write this out, we can do all the combinations, and we're going to look at the 5 rounds in the 7 total. So we're going to, that will tell us, that 7C5 will tell us how many of these there would be. So we're going to have to add this number to this one to this one. They're all the same number, but we'd have to add it this many times. So 7C5, let's see where I worked this one out. 7C5 is 21. So I would have come up with 21 of these with the same set of numbers. So I can account for that by going 21 times this set. So now I have all the numbers I need. So when I calculate 21 times 7, 6, 5, 4, 3 times 5, 4, that number divided by this, I got the answer. And it is right here. So here's where I multiply those numbers out. And I got these numbers, which was giving me a decimal of 0.265. So that's like, this will happen 26.5% of the time. All right, let's look at number 5. All right, talking about the same problem. What is the probability, sorry about that glare. What is the probability that at most 6 are round? So we're going to talk about that word at most. So that means the probability is asking for the probability of, we're drawing 7 round we're drawing, how many were we drawing? 7? We're drawing 7. So what's the probability that at most 6 are round? At most means, well, there could be 1, 2, 3, 4, 5, or 6, but not 7, because it says at most 6 are round. So do you see our strategy will be, we could find the probability of drawing 0, 1, 2, 3, 4, 5, and 6 and adding them together, but it's easier to just find the probability of this not happening and subtract it from 1. So the probability of most 6 we're going to be 1 minus the probability of 7. So that's my strategy for that one. And when I did that right here, sorry, I'm trying to zero in on the work there. The probability at most sixths were round is going to be 1 minus the probability there 7 are round. So I'm going to work at first the probability of finding 7 that are round. So I drew 7 blanks, and 7 on the bottom are the same as at the top. These are all the possible ways we can draw from the rocks with no restrictions. But here we have the restriction of drawing 7 that are round. So these are all round. 7, 6, 5, 4, 3, 2, 1. And we see that the combination of 7 taken 7 at a time is 1. This can only occur in one way. So we don't have to multiply like we did up here by a number. So now we have this over this. That came out to be 0.0012662626. All right. So I want to make 2 videos out of this. So we're at number 5, a good stopping point. See you part 2 with number 6.